Hello, Algebra 2, Semester 1 students. This is Mr. Bear bringing you Skill 5, which will cover systems of equations through graphs. So before we do that, let's just talk about what a system of equations is. A system of equations is two or more equations that have some sort of relationship and share the same variables. We can graph them as one method for finding the solution or possibly solutions to a system. So we're going to look at a few pictures and we're going to determine how many equations the system represents and how many solutions there are graphed in each system. Okay? So we've color coded the equations. So looking at this first graph here, this one right here, we have two distinct lines. We have a red line and a blue line, so there are two equations. Now, a system of equations, the solution to a system of equations is going to be what x and y values both equations share. So where do we have a solution? It's going to be where they cross. So in this case, we have one solution. The next one is a little bit hard to tell, but just know that they were using blue and red lines. And here, when you put a blue on top of a red, you get purple. So I want you to know on this one, there are actually two equations. These lines, it's two lines on top of each other. So it's made up of two equations, but the equations end up, when you solve them for y and simplify, they end up being the exact same equation. So on this one, we would say there are infinite solutions. And that happens when your two equations boil down to the same line. And then when we look at the next one, we have two parallel lines. They're parallel because they have the same slope, but they have different y-intercepts. This one's down here, and this red line, it's going to end up being up here somewhere. Okay, so there are two equations on this one as well, but there's no solution because they don't cross. All right, and those are the ones we'll primarily be working with, but I wanted to show you that systems don't have to just be lines. Systems can be other objects as well. So here I've got what happens when you try to cross a line with a parabola. So if you look at this example, the orange graph is the parabola, the blue graph is the line. So that means there's two equations, but no solutions. Okay, it's no solutions because they don't cross each other. The next one, you can see, again, we have an orange parabola and a blue line, so that would make two equations. But they're only going to cross in this one spot, so there's one solution. You could also see a line that crosses a parabola in two spots. So the orange is the parabola, the blue is the line. So again, two equations. And we're going to have two solutions. So in the linear cases, so when you have two lines, there's no way that two lines can cross each other just in two spots. But in the case of a parabola and a line, it can cross in two spots. So depending on what kinds of equations you're looking at, you could have multiple types of equations. All right, but generally, when we're talking about a system of equations, the solution, or should I say solutions, to a graph of a system of equations is where the graphs cross or intersect with each other. In the case of this last one, the parabola with the line, you would have to find what both of those solutions are, and there will be techniques that you'll learn later on how to do that, but we won't cover them in this course. There is also the possibility that we could be talking about equations with three variables. So there is that possibility as well, but we will not be looking at any of those this year. So just know that these are just a very limited set that we will be looking at. We just wanted to make sure that you understood what it means to have a solution. So in each of these 6 situations, we're basically saying that a solution occurs anytime that two objects or two graphs cross each other. Okay? All right. So, like I said, we looked at graphs where there were 2 lines as well as a line and a parabola. There are many other types that we can look at, but we're going to focus on equations with 2 lines. So just a little bit of recall, when you were in Algebra 1 or maybe even before, you learned that you could graph a line easily when it's in slope-intercept form. Okay, and that looks like y equals mx plus b. M told us our slope, and the y-intercept tells us the b. Or the b tells us the y-intercept, should I say. All right, so what we're going to focus on today is how to graph a system of equations. And so what we're going to do is follow a few steps. So these are really important steps. If ever you get stuck in being able to graph a system, refer to these steps to help you. First thing to do is make sure that both equations are solved for y. That makes it easier to graph. Once you have it solved for y, then you're going to graph each line. So the way you do that is you plot your b value, which is your y-intercept. You're going to plot that on the y-axis, and then you're going to use your slope to find another point. All right, so you're going to have to really understand what the equation of a line does and how it helps you to graph. Then we're going to look for the intersection point if there is one. Okay, if the lines intersect in one point, the solution is written as an ordered pair, which we write as x comma y. If the lines do not intersect, meaning that they are parallel. If they're parallel, then we say there is no solution. And if the lines lie on top of each other, we say that there are infinite solutions. Okay, and that would be where they basically are the same line. Okay, so looking at those steps, let's try them. We're going to start easy with a couple of systems where it's already in slope-intercept form. All we have to do is graph it. And I'm going to color code on here, so I'll make the top equation red. So I'm going to put a little red dot. Y equals negative 5/3 x plus 3. Well, to graph that, I start with my b value. So remember, these are all in y equals mx plus b form. The b is the value at the end, so plus 3. It's a y-intercept, so I look at my y-axis, and I plot the plus 3. Okay. Now we're going to use our slope. Our slope is negative 5/3. So from this y-intercept point, I'm going to go down 5. So negative 5, 1, 2, 3, 4, 5. And then I'm going to go over 3. 1, 2, 3. Okay. And when we draw our line, it will look like this. All right, so now I am going to look at this next one. Y equals 1/3 x minus 3. So I'm going to go down to minus 3 on the y-axis. And my slope is 1/3. It's positive, so I'm going to go up 1 and then over 3. Okay. Now, when we look at this system, our solution, in this case, we see one definite location where things cross. So what we're going to do is we are going to say that the solution The solution is going to be the ordered pair. We're going to put the x value first. So remember, x is horizontal. So my x value is 3. And my y value, remember that's the vertical direction, the y value is negative 2. So our solution is 3, negative 2. Okay? All right, for the next one, I'm going to graph this one a little bit more quickly. I have y equals 4x plus 3, so I plot my plus 3. Now my slope is 4, so think of that as 4 over 1. Now notice that on this graph, I can't go up 4 without going off the graph. So just remember that 2 negatives also make a positive. So when you're in that situation, you could go down 4 and left 1. Okay. There's your graph. I'll do the next one. Y equals negative x minus 2. So I'm going to plot my minus 2. Slope is negative x, so think of that as negative 1 over 1. So I'm going to go down 1 and right 1. And we can see once we graph it, we have an intersection point. So our solution here is going to be negative 1, negative 1. Okay. All right, let's look at how to graph a system where we don't have the y solved for. So x minus y equals 3. I'm going to solve this for y. So what I'm going to do first is I'm going to subtract x on both sides of the equation. And I get negative y equals negative x plus 3. Notice that I rewrote the 3 minus x as negative x plus 3 because we want this in the form y equals mx plus b. So the x part needs to come right after the equal sign. Now remember, this is a pretend negative 1 in front of the y. So we're going to divide, and there's also a negative 1 in front of the x. So we're going to divide everything by negative 1. So we get y equals, let's see, 2 negatives divide to a positive x, and a positive divided by a negative is a negative. So y equals 1x minus 3, so I'm going to plot my minus 3. And I'm going to go, my slope is 1, think of that as 1 over 1, so up 1 over 1. My line's a little bit off here. There we go, make it a little bit better there. All right, now we have to do the same thing for the other equation. We'll do this work here. So we have 7x minus y equals negative 3. So we're going to first subtract 7x from both sides. That gives us negative y equals negative 7x minus 3. Remember, that's a pretend negative 1 in front of the y, so we're going to divide everything by negative 1. And we get y equals 7x plus 3, because 2 negatives divide to a positive. So I'm going to plot my plus 3. Now in this case, remember that 7 is 7 over 1. I can't go up 7 and over 1, so I'm going to just multiply top and bottom by a negative. 2 negatives make a positive, so I'm going to go down 7, and left 1. And we can easily see now that there is a solution. The solution is that my x value is negative 1, my y value is negative 4. And that's our solution. All right, last one here. When I look at this one, we have 4x plus y equals, 4x plus y equals 2. To solve this for y, we're going to subtract 4x from both sides. That gives us y equals negative 4x plus 2. Okay? All right, looking at that equation, we can see that, that needs to be graphed. So plus 2, negative 4, think of that as negative 4 over 1, so go down 4 and right 1. I'm going to modify the second equation here. I'm going to change this equation just so that we can see what happens with it. I'm going to call it 8x plus 2y equals, let's say, -4. The reason I'm doing this is so that we can see another case here. So I'm going to show that work down here. So I'm going to solve this for x. I'm going to subtract 8x from both sides. And that gives me 2y equals -8x minus 4. Divide both sides by 2. We get y equals -4x minus 2. All right, so graphing this, we're going to graph our y-intercept of -2. And on our slope, -4/1. I can't go down 4, so remember this could also be 4 over -1. Doesn't matter where your negative is. So I'm going to go up 4 and left 1. And when we look at this situation, we have two parallel lines. And I know this because we have the same slope. So there's no solution. Okay. All right, so now we've had a chance to practice graphing some systems of equations. So in class, we're going to talk more about graphing systems, and then we will do some practice with it.